We're at gotomath.com. We got to pause for a station identification break. Definite integration. Definitely it's integration. Let's see. I think we're doing, figure out what we're doing here. I guess we're doing that one. Click on it. All right. Find the definite integral, round to 3 decimal places. Okay. We got the integral, 5 pi thirds, let's see, pi 6, cosine 6, cosine. Okay, well, let's just write all that down. Let's get it written down. Let's do it. 5 pi 6, 5 pi thirds, which is 60 degrees, pi 6, which is 30 degrees, right? 6 cosine x dx. So we covered this trig functions there in in the section of indefinite integration. So hopefully you got that down. So we're doing, let's see, pi 6, write that, and 5 pi thirds. Promise I won't talk about Santorini anymore. No, just kidding. No, actually I am kidding. I'm not kidding. Something like that. Cosine x dx. I think you might get tired of me just talking about math all the time. What are we doing? We're taking the integral. So remember, I always write this up here. F of x is equal to cosine x, right? And then if I said, okay, well, what's f prime of x? F prime of x is negative sine x. So it's going to be a sine x, but it's not going to be with the negative, right? So when we do the integration, this stuff gets flipped around. So it's not negative. So the integral of cosine x is just sine x. So we just rewrite the coefficient, 6 sine x. That's it. Trying to make this stuff as simple as possible. 5 pi thirds. Alright. So we'll go ahead and click that in. 5 pi thirds, plug it in. So we have 6 times the cosine. Why did I write the cosine? I'm not sure. With a wave of my hand, it disappeared. Sine is what I meant to write. Sine of 5. Wow, I said 5 and wrote a pi. 5 pi thirds. I think something was in that hot chocolate I just drank. 6 times sine pi sixth. Right. So we remember what pi thirds is. That's 60 degrees, and there's 5 of them. So that's 6, 30, 300 degrees. Anyway, we got to remember what this stuff is now. Sine of 5 pi thirds. How can we figure this out? Well, we got plenty of time. We got all kinds of time. So pi thirds, here's the key right here. Pi thirds, okay, its degree equivalent is 60 degrees, okay? So if I'm going, let's say this is 60 degrees here. So we'll say this is 60, right? So we go 60 degrees, so we got 30 degrees, okay? So this would be, how many of these we got to do? Let's see. Here's 60, and then here's another 60, and then there's another 60, and this thing is symmetric, so we try to make it symmetric. 60, 60, another 60, another 60, and another 60 there. Well, how many 60s are we going? We're going 5 of them, right? That's supposed to be a 5 there. 5 pi thirds. We're going 5, so let's count. 1, 2, 3, 4, 5. So we're in this quadrant, and this is what's important, okay? And since it is, let me just try to do it. Whoa, it's supposed to spin a triangle there. Okay, so since this is sine, this is your y value, and that means that this number is going to be negative because we're in this quadrant right here. We end up in this quadrant, right? Okay, so we know it's negative. Now here's the other one. Okay, and that is, so there's two values you need to remember. A half, the square root of 2 over 2, well there's three of them, but really, and the square root of 3 over 2. So these are the ones you need to remember. Now this one here is always going to be pi fourths. Okay, this guy will always be with pi fourths here. All right. Now, if we're looking at sine, right, that's going to be this distance right here. If we're looking at sine and we're in this quadrant, okay, and this is where we're at, well, if you notice, we're trying to reason this out, all right? If you notice, this side right here is going to be longer than this side, okay? This is why. This side is longer than this side. Well, which one is bigger? The square root of 3 over 2 or a half? Well, the square root of 3 over 2 is like, I can't remember, 0.86 or something like that. And we know this is 0.5. So this is going to be the larger one. Okay, this will be the larger one. This will be the value that we're going to use right here. You see, so that will be it. So this is going to end up being, but it's negative because it's down here in this quadrant. So we're going to end up with negative 6 times the square root of 3 over 2 minus 6. All right. Now we're doing the sine of pi 6. Now we're going to be up here in this quadrant. And the pi sixth, the radian degree, is associated with 30 degrees. 30 degrees, right? So here's 30 degrees. If this is 60, then we'll take half of that. Okay, we'll say this right here is 30 degrees. And we'll just do something like that, even though these should be lined up, I guess. But anyway, so 30 degrees. Now this side, as you can see, which we'll call y, and this side x here, is, right, this side is shorter than this side here. Okay, so therefore this guy right here must be associated with a half, must be associated with a half. So you know, on the whole trig wheel thing, if you can just remember pi 6 is 30, pi thirds is 60, and remember these three guys here, right, and of course pi fourths is 45 degrees, but if you could just remember these, okay, we can reason this thing out. Okay, and so sine of pi 6 ends up being a half. So there you go. We reasoned it out. It took a long time, but we did it. And it's important that you understand what's going on here. Okay, that's how I do it. Half of 6 is 3. We can reason that out, couldn't we? Let's see, that's going to be 3. So let's just write this. Negative 3 square roots of 3, and then minus 3. Alright, but I think it said to round to 3 decimal places. Boy, 3 is kind of popular today, isn't it? So let's hope that I did that right. We're going to find out. We got negative 3 times the square root of 3 minus 3. And what did I just do wrong? Oh, put something under the radical. Never mind. Alright, square root of 3. Let's see. Negative 3 times square root of 3 minus 3. Okay, let's hope I did this right. Negative 8.196. Negative 8.196. I was holding my breath on all that, let me tell you. Woo. Anyway, there it is. It was live. Alright, come on by. Go to math.com. Remember, this is the 8ball.com. No. Anyway, and I'll see you there. See you there. Bye.